Stanford University.
All right, well, welcome to lecture number 9 of CS193P, fall 2013-14. Today I'm going to finish the animation demo that we started on Monday, and then the lecture is going to be about auto layout, which is a really cool system for making it so that your user interface can adapt to changing conditions. And then I'll do a brief auto layout demo at the end, just so you can kind of see it in action. Seeing is believing, especially with auto layout. So this demo, where we left off is the blocks would come down due to gravity and they would collide at the bottom and they'd kind of run into each other. And then when a bottom row was full, they would all kind of fly off into outer space. And I think where we left off too is they would stack up and they weren't flying off. Okay? And so why weren't they flying off at the end? Well, part of the reason they weren't flying off was because those towers of blocks were so tippy. They were kind of wiggling and they were never coming to rest. Okay? So they were never, the animation was never stopping. It was always continuing to move them a little bit. And so we're going to start off our demo by making those stacks a little more solid, a little less tippy, by making it so that the blocks can't rotate. So since they can't rotate, they'll sit on top of each other much nicer. And I'm going to turn gravity back up to 1.0. I think I typed in 0.9 at some point, just as part of the demo. But let's crank it back up so that they will sit a little bit so they don't float at all, you know, so they sit down strongly on top of each other. Then what I'm going to do is use an attachment behavior so that as a block falls, we can grab onto it. Okay? And then we can kind of swing it around and pick which stack we want to drop it in and then let it go. And then the last thing I'm going to do is we're going to use the action block of that attachment behavior to animate that and show the attachment. I'm just going to actually draw a little line to show it. So there's quite a bit to show there. I don't think we're going to have time to do this collision delegate thing, but I'll post the code for that so you can see what that's all about. All right, so let's get back over to Xcode here and go back into drop it. And okay, so remember that we moved all of the behavior of this thing out into its own subclass of UI dynamic behavior called drop it behavior right over here, this guy. And so that's where the gravity and the collision is. And so what I'm going to do there is I'm going to add another behavior to that custom behavior, which lets us control things like whether the blocks rotate. Okay? We could also control friction, resistance, density, those kind of things in there. The kind of behavior that controls those things is called a UI dynamic item behavior, because it's specifying the behavior of that item. Okay? So we'll call that maybe something like animation options or something like that. You could call them item behaviors. You might call them physical characteristics almost, but we'll do that. And let's go down here and lazy instantiate that. So dynamic behavior, animation options. If not animation options, then animation options equals UI dynamic item behavior alloc init. So I'm just allocating this thing. And I'm going to allow rotation. No. So I'm not going to allow these items to rotate. Okay? So the blocks will have to stay, as they bounce on each other and collide, they'll have to stay non-rotated. All right? And return animation options. And again, we could do other things in here like dot friction equals, dot density equals, whatever, but we'll keep it simple. I obviously want all items to be added also to this animation adoption thing, and we clearly want to remove all items as well. And let's finally add our child behavior. Animation options. So the animation options act like any other behavior. Okay? They just specify attributes instead of, you know, applying the forces or whatever. But you can actually think of them somewhat as applying forces too. It's just, you know, like forces to keep them from rotating or forces to make them have higher friction, those kind of things. Okay, question?
If they conflict, do they resolve like forces
differences?
What a great question. You mean if you had multiple item behaviors that had different conflicting densities or whatever? So that's a great question. There are rules for that. If you have a tree of behaviors and you had some item behaviors in there, there are rules for which one wins. It's kind of the last one wins, and how that happens is all defined in the documentation for it. So if you're going to build a tree so complicated that you have the items in there twice with two different behaviors and different things, I mean, that's pretty, I mean, if you're doing that, you really got to know what you're doing. And so you really want to read the documentation. That would be considered advanced behavior to do that. But it can be done. It is legal. OK, so now we'll have that. So now when we run this, we'll get a little less of the tippy stack thing, although I didn't change the gravity, but we'll see what happens here. But you can see they're definitely not twisting. They're staying. They still might bounce slightly to the side if they, for example, if I click too fast, they might crash into each other on the way down, ones that are in the same column. So here we go. So now they're going to be flying away a little more reliably. Let's try going really fast, see if we can get them to tip a little. Now, if I have multiple rows, they should all go together. Notice also I'm starting to get a lot of blocks, and the performance is starting to get a little jerky, okay? And that's something you have to understand with animation. If you have a lot of things animated, it's not free, okay? Animation is not free. And if you had an application like this where you were dropping these blocks and you allowed the user to drop a lot of them, you might have to start doing some other things. Like, for example, instead of having the collision, instead of having all the items collide with each other, what if you just drew a boundary around the top that top ones could collide to? You see? Then you would keep all those bottom ones from having to calculate where they're going to go, because you'll notice that after they get tamped down a little bit, they don't bounce so much at the bottom anyway. So you could take away that bounce and put a boundary, because your boundary is a UI Bezier path, could be anything you want. Okay? So you have to think about that only, when you start to get to extreme cases there. Okay, everyone cool with that? Make sense? All right, so the last thing we're going to do is this attachment behavior. So this is just attaching that bar, which can be a springy bar or an iron bar. I'm going to leave mine be an iron bar, a bar that doesn't collapse and expand. And we will use that bar to grab onto one that's coming down so I can swing it into the right column. Because right now, it's just whatever column it comes down in, that's the column it goes in, and that's a little bit restrictive. It makes it hard for my game to play very, very competitively. And so what we're going to do this, we need a couple of things here in our view controller. One is we're going to clearly need an attachment behavior. So I'm going to create a new UI attachment behavior. I'm just going to call it attachment. Okay. And I'm also going to need to know which view is dropping. Okay. The view that's currently falling down, because that's the one I'm going to grab on. Because there's a whole bunch of views in my game, right? Tons of them all over, stacked up there. Which one, when I start grabbing, am I going to grab onto? It's going to be the dropping view. So I'm going to have to keep track of the dropping view. And in fact, that's easy to keep track of. I'll just write down here, every time I drop a new one, I'm going to say the dropping view equals the drop view. Okay, so every time a new one comes down, it's going to become the one that gets grabbed. So if I have multiple of them coming down at once, it's the last one that started coming down is going to be the one that gets grabbed if I grab onto it with this attachment. Okay, so now I have the dropping view. So I'm going to do the attachment with a pan gesture. Okay, so we're going to see another gesture recognizer here because I'm going to grab it, and then as I move my finger around on the screen, I'm going to keep the attachment attached to my finger. So the block that's being grabbed onto with the attachment, it will kind of follow my finger around, right, with a bar behind it. So that'll be kind of fun. So let's do that. So you remember the gestures we set up, right, from our storyboard, right? Here's a storyboard. I'm going to go over here and grab a gesture. It's a pan gesture, which means follow the finger around. So here's a pan gesture. Drag this out. I'm just going to drag it on top of my game view, right on top here. Here's my tap gesture. Here's my pan gesture. So I'm going to drag it out. I'm going to put it down near where my tap gesture is. Here's my tap gesture right here. So I'm going to put my pan gesture right next to it. I'm going to call it pan. I'm probably teaching a bad style here to call these pan and tap. I call them that so that when you see them, you realize, oh yeah, that's the pan gesture handler. But again, this could be something like grab, drop. That might be a better name for this than pan, okay? So there's our gesture. And let's make some more space. And actually, we don't even need to see, actually, let's go back here. We don't need to see our storyboard for this. Okay, so I've got my pan right here. So what's going to happen in this pan? Okay, pan gestures like pinch gestures and continuous gestures like that, they kind of have a similar sequence of events that goes on. So I have a little snippet that I do the same thing for all these kind of gestures, which is they start out, they begin, then they change as they move around, and then they end. So what are the three things we're going to do for our pan gesture when we do our attachment? Well, the first thing I'm going to do, actually the first thing I'm going to do is I'm going to find out where is that pan gesture? Where did that happen in my game view? And I'm going to do that with CG point, gesture point equals sender location in view, my game view. Okay, so now I know where in my game view that happened. So this is a gesture recognizer, right? This sender is, and this is a method in pan gesture recognizer, which tells you the location the pan happened, or is happening if it's moving around. It tells you the new position. So the first thing I'm going to do is I'm going to attach the dropping view, that thing we just said, to that point, the gesture point. Okay, so this is a method we're going to have to write. So I'll put it down here so that we remember to do it. Although we might remember better if we don't put this down here, but because they keep complaining, we'll do that. So I'm going to have this attached to dropping view. That's going to be the guts of doing an attachment thing. Here, when the pan changes, when it moves to a new spot, I'm just going to have my attachment behavior anchor point. Okay, anchor point, remember, the attachment can be either attachment between two items or between an anchor point and an item. This is going to be between an anchor point. That anchor point is going to be following my finger around. I'm going to set that to be the gesture point. Okay, so that's all I'm going to do when it changes. And then when it's done, I'm going to remove this attachment, remove behavior, this attachment from my animator. So my animator is going to stop doing that animation anymore. Okay? So that's it. You can see this is all pretty easy to do, all this stuff. Even this attach is going to be really straightforward. So let's look at that attach. How do we create an attachment behavior between an anchor point and some item? And it's very simple. If we have an item that's currently dropping, okay, hopefully we do, then we're just going to create a new attachment behavior with UI attachment behavior, alloc, and it's init. It has, remember, 4 different kinds of inits here, depending on whether you're attaching to points or between two items. It also has some ways to attach with an offset so that the iron bar is not connected to the center of the thing. Maybe it's centered a little offset. It'll kind of tilt a little bit. So I'm going to do the one which is init with item attached to anchor, which is this one, I guess. Yeah. And the item is going to be that dropping view. Oops, sorry, attached to item. No, I wanted a different one. I want attached to anchor. And the anchor is going to be that point, right, where my pan gesture went down. So that's it. It's as simple as that. Now I have an attachment between that point and this dropping view. I'm going to be moving that point as the gesture moves, and the dropping view is just going to follow around. After that attachment happens, by the way, I'm not going to allow you to do it again, so I'm going to set the dropping view to nil. Okay? Because in other words, I'm not going to let you grab onto that thing, move it a little, oops, grab onto it again, move it again. Nope, you get one try. Okay, this is part of the gameplay. I only want you to get one try at dropping that thing. And then I just say animator, add behavior, and the instant I do this, it's going to start animating that. Okay, animating an anchor, a connection between that point and that view. Okay, so I think that's all I have to do. Yeah, so let's run and see if this works. All right, so we have them dropping down. I grabbed onto it. You see how? See my mouse? You can see how I'm kind of have a hold of it, and it's like a bar. I can even balance it on top of it. You see? It's a little hard to see, right? So maybe we'll draw a line between the attachment point and the little thing. Okay. Woo. Okay. So that's the next thing I'm going to do is I'm going to draw a line between where I'm panning and the item that I'm dropping. So let's do that. And I'm doing that not as much, partially to show you how the attachment is working, but also because I want to show you how to use this action, this little action block that you can use. So how am I going to draw that? Okay, how am I going to draw this, this line? Well, what I'm going to do is I'm going to make the game view of my storyboard here be a UI Bezier path drawing view. Okay, so I'm going to create a new kind of view. Oops, new file, and it's going to be a UI view, subclass of UI view. I'm going to call it Bezier path view. Okay, and this is going to be a totally generic Bezier path drawing view. So its public API is it is going to have one property, public property, which is a UI Bezier path called path. All right, that's its entire public API. And all it's going to do is in its drawRect, it is going to say path stroke. Okay? And the only other thing I'm going to do is self.path. And the only other thing I'm going to do here is in set path, the setter for that thing. I'm going to do under our path equals path, and I'm going to say self set needs display. So anytime someone changes the path, it's going to redraw it. Okay? Everyone understand what this class does? I hope. Right? This combines everything you know about drawing, right, in one thing. drawRect, Bezier path stroking, set needs display, the whole thing. So that's it. Now I'm going to go back to my storyboard, and I'm going to have this game view, instead of being a UI view, I'm going to change its class to be Bezier path view. Okay, so everyone remember what I told you about. If you have a custom view like this, if it starts out generic, when you drag it out, right, it starts out generic, and you can change its class, just like with the controller. Okay, now to match this up in my controller, I better go up here that this is a, where is that thing? My game view is a Bezier path view, so let's do that. Bezier path view. Oops. All right, so it's a Bezier path view, so that I can send it Bezier path messages. Okay. All right, so now my game view can display an arbitrary Bezier path. So now all I have to do is calculate the Bezier path between that the attachment shows, basically between the anchor point and the dropping view. And then every time that attachment view changes, I have to redraw. I have to reset that path, recalculate it every time. Okay, so that's where this action block is going to come into play. All right, so how are we going to do that? Let's do it right in here. Okay, when we create this attachment right here, we are going to use the little action block of this guy, action, to update that thing. So let's go caret, curly brace, okay? This is how we specify a block. So we're going to pass this block of code off to this attachment, and every time it animates, it's going to call this block of code. And what are we going to do in this block of code? Well, we're going to create a Bezier path. We're just using UI Bezier path alloc init. And this Bezier path needs to have a move to, so let's have it move to the anchor point of the attachment. So that's self.attachment.anchor point. And then we're going to path add line to. We need to go to where the dropping view is. That's self.droppingView.center, right? And now we have that path, so I can just say self.gameView.path equals path. Okay? Any questions about this? Yeah.
Why do you need to go and attach it to self.attachment.anchorPoint? Aren't you passing an anchor point into that method already?
Yeah, so the question is, couldn't I just say right here, anchor point? Because I'm passing anchor point right here. And the answer is no, I can't do that because I'm changing the anchor point, right? Every time you move that pan, I'm changing that anchor point. So this block of code gets executed every time that happens, so I can't use this anchor point, which was only passed in here when I first attached it. I have to use self.attachment.anchor point. In other words, the anchor point's current attachment point, right? So that's why I have to keep calling that, yeah.
self.dropping view to nil after you set that block, will that affect what happens in the block?
Yeah, excellent question. So I'm setting this self.dropping view to nil, and I'm using self.dropping view in here. Isn't that going to break it? And the answer is absolutely it is. Okay, I did this intentionally because I wanted to show you that the things that are in here get reevaluated every time. This block gets executed each time the animation happens. So how can I deal with that? Well, I can just, how about create a little local variable here called dropping view equals self.dropping view. And then I will use that right here. Okay, so now I've captured the dropping view here in a local variable, and I'm using it here. So this is referring to this local variable, not to self.dropping view anymore. And the fact that I set this to nil doesn't matter. This one's still going to be pointing to that thing. Okay, so that I just wanted to kind of show you how blocks capture the local variables that are just outside their scope. Now, we have another problem in here, and in fact, the compiler is warning us about it. You see, capturing self strongly in this block is likely to lead to a retain cycle. That's a memory cycle like we were talking about. And in fact, it's going to, because this action, this block, is inside this attachment, strongly held by it, which is strongly held by us. So we have a strong pointer to this block. And if I put self in here, the block is going to have a strong pointer to us. And that's no good. So we're going to do this trick, underbar weak. UI, what do we call it? What is the name of this thing? Drop it, a view controller. That's our self. Weak self equals self. So now I've created a weak pointer to myself, and now I can use that here, weak self. Okay, also down here, weak self. All right. So if I ever got dropped out of the heap, and no one had a strong pointer to me, these weak self pointers would all go to nil. But that would be fine, because if I'm not around, then this action doesn't mean anything anyway, right? I'm the controller. So it's all perfectly fine to do that. Okay, any questions about what we did there? Because that's an important thing to understand as well. All right, one last thing we have to do is when the gesture ends, the pan gesture ends and we remove the animator, we're going to want to say self.gameView.path equals nil. Okay? Because this action, once this thing is removed from here, this action is not going to execute anymore, so we're not going to get that last action that draws nothing, right? We don't want that line to be left there. Okay? In fact, here, you know, just to make sure you understand this, I'll leave this out and we'll see what happens. Okay, so I'm dropping here, and now see, look, I got my bar. Dance this thing around, woo, drop it where I want. Oh, see, the bar didn't go away, okay, because that action never called. That's because of this line of code. So let's put this back. Now we'll run. Okay, now we drop one, we got it. Drop another one, grab onto the side, another one. Try and swing it around. Okay, if we swing it around and smash it in there, they'll still collide. Okay, these are still collision, still happening. And you can see also that our game has a little bit of a problem right now. By the way, this not being able to rotate is why it didn't tip off there. Okay, because it kind of got stuck. It's with being some item behavior is keeping it from tipping off. Okay, this is bad for our game because how are we ever going to line these blocks up here, right? So the next thing we would want to do, and this is what I'm not going to do because of time here, is in the collisions, okay, when collisions happen, collisions have a delegate as well. And in that delegate, what you could do is every time, and the collision delegate tells you when a collision starts and when the collision is ended being processed. Okay, and in that ending handler, the ending message that gets sent by the collision to this collision delegate, in that ending thing, you would then grid the thing up. Probably look at its linear velocity. If it's moving to the right, move it to the right a little more until it lines up. If it's moving to the left, move it to the left a little more until it lines up. See? So it's not too many lines of code, but I want to make sure we cover auto layout today, so we won't do it. But any questions about what we did so far, or what we did here? Okay. Yeah, oops. Okay. All right, so let's get on to the lecture about auto layout. Where's my keynote? There it is. Okay. So what is auto layout? So auto layout is a way of setting the frame of all your views, okay? And these can be frames of views that you make in code or frames that you drag out into your storyboard, okay? Although I'll warn you for your homework, the frames of the cards that you make in code, you're probably not going to want to use auto layout to lay those out. You're going to want to use like that grid class I gave you or some class you write, okay? Because the rules for laying them out are kind of beyond even what auto layout can do, okay? So that's just a little hint there. But all the other views, every single other view, including the view that contains your cards, you'll want to use auto layout to decide where it gets put on screen. So we're going to decide where to put these frames using rules instead of using numbers. Instead of saying putting it 2020, 180 wide by 200 high, we're going to use rules to decide where it goes. Okay? And these rules are really flexible and powerful, and the rules are mostly about the relationship between one view to another view or between a view to its superview. Okay, now why do we want to specify these frames as rules instead of as numbers? Because sometimes the bounding rectangle that contains all our views is changing, either because device rotated, we're on a tall iPhone versus a short iPhone, we're embedded inside of a navigation controller or not, we're in a tab bar or not, we're on an iPad in some popover controller view or something like that. There's a lot of reasons that our bounds would change size. So we want to build our views so that what's inside of them adjusts automatically, okay? And that's a big part of your assignment, although your views want to, in terms of your cards view, want to adjust automatically anyway because you're adding and removing cards from them, and so they have to adjust anyway, so you kind of probably get that for free. But all the rest of your views, the one that says redeal and score and all that, you're going to want to use auto layout to make those fit in the right place when you rotate the phone. Now, these rules, by the way, we call them constraints, layout constraints. So that when I use the word constraints, that's what I'm talking about, the rules for how to set the frames of all these views. There's a really powerful API in iOS for this. In other words, a programming interface with objects and its layout constraint and all these mechanisms. But really, almost all of what we do with auto layout, we do in Xcode visually. We don't usually go to the code. If you're going to the code, you're doing some pretty advanced layout. Okay? I'm sure it's possible actually with the code. You could lay your cards out using auto layout, but Xcode probably not. Okay? So since it's all Xcode and it's all graphically, I'm going to do this entire lecture about auto layout with screenshots. Okay? And we'll just kind of walk through it. I'm actually going to skip these first few here because I'll show you that in the demo. So what I'm going to do is I'm going to start with a view, controller's view right here, with a couple of things in it. Thing 1 and thing 2, with apologies to Dr. Seuss. Things 1 and thing 2, they could be any kind of view. They're UI labels in this case, but they could be buttons, they could be custom views, whatever. They're just thing 1 and thing 2. And we want thing 1 and thing 2 to be in the right place when this bounds changes. Okay? So what happens right now, if we go and try and show this in landscape? Well, I could run this and then flip the simulator to landscape to see, but it's actually possible to take your view controller scene and flip it to landscape in Xcode. Okay? Now there's two ways to do it. One is Xcode actually has a previewer that will preview what your UI is going to look like on different rotations, different iPhones, even between iOS 7 and iOS 6 if you're writing an app that's compatible for both. But another way to do it is just to inspect your controller. So here I've selected my controller, right? It's got a blue boundary around it. I've selected it. And I went to the attributes inspector, you see, upper right there. And I'm inspecting it. And if you look at the inspector for controller, the top 5 things there are called simulated metrics. And this is a way to simulate your user interface in different orientations or sizes or with tab bars or not, so that you can kind of make sure your UI is working with auto layout. So we're going to go and switch the orientation. All right, so I'm picking on this thing orientation, and I'm switching it to landscape. And when I do that, my scene changes to landscape, and I lost thing 2. Okay, what happened to thing 2? Well, thing 2 is actually there. I left it there. It's kind of grayed out. You see it, but it's not on screen because unfortunately in landscape it doesn't go down far enough to reach thing 2. Okay? So I'm going to switch back. By the way, you notice that the orientation there's portrait and landscape, and there's also inferred. Okay, for all of these things where you change the bounds of your scene, inferred means inferred from what's going on in your storyboard. So if it's, this is the thing that makes a bar come across the top if this scene is in a navigation controller, or a bar across the bottom if this scene is in a tab bar controller, okay? Portrait is the default inferred orientation. So if you pick inferred, just like you pick inferred for the other things, it will infer that you mean portrait. So whether you say portrait, landscape, portrait or inferred are the same for orientation. Landscape means landscape. So let's go back to inferred or to portrait. We get thing 2 back. Whew, okay, thing 2 didn't go anywhere. It was there before, it just wasn't on screen. So I want to put thing 1 and thing 2 in better places. They're kind of in random places. I want to put them in places where I can have a rule that says where they are. And then what I'm going to do is I'm going to put thing 1 in the upper left corner, and I'm going to put thing 2 in the lower right corner. And I always want thing 1 and thing 2 to stay in those corners, no matter where those corners move. Okay? If those corners move up in a landscape or down because it's an iPhone, the tall iPhone, like an iPhone 5, or up or whatever, I want those things to stick to their corners. So the rules I want is sticking the corners. Okay, I'm going to show you 3 ways to set rules over the course of this lecture. 3 different ways. The first way you've already been doing unwittingly. Well, not really unwittingly because I've been telling you to do it, which is to use those blue guidelines. Okay? When you drag things around and you let the blue guidelines snap to certain locations, you're basically telling Xcode what you want. So when I drag thing 1 up into this upper left-hand corner and these 2 blue lines appear, it's really telling Xcode, yeah, I want it to be stuck to this line and stuck to this line. In other words, upper left there. And same thing when I do that for thing 2. Okay, I'm kind of telling Xcode. But if I drag these 2 things here and right, and then I switch over to landscape again, I still don't get thing 2. Why not? Okay, I did the blue lines. How come it doesn't work? And the answer is, all the blue lines are is telling Xcode what you intend. You still have to ask Xcode, make those rules for me. Make those constraints. Okay? So let's go back to the portrait orientation. And the way you do that is the little buttons at the bottom. You see these buttons at the bottom? Here I'll click on auto layout. Okay? And how are you going to lay out the view? And this one that looked kind of like a TIE fighter, a Star Wars TIE fighter there, that one is kind of for resetting, clearing constraints for the entire view, okay, or for a specific view or number of views that you have selected. So the bottom part of this menu is the entire view. The top part is the same things, but for specific clicked-on views, okay? So we'll go through a few of these things, but one really cool one is reset to suggested constraints, okay? Suggested constraints means Xcode is going to suggest to you the best constraints, the best rules, and it's only going to be very good at that if you use the blue guidelines. Because if you don't use the blue guidelines, it doesn't really know what to suggest. It'll suggest something, but it's not going to be good, as we'll see. But in this case, since both thing 1 and thing 2 clearly have blue guidelines to say where they want to be, when we do reset to suggested constraints, it's going to work. Now, nothing appears to happen, right? I did reset suggested constraints, nothing happens. But something did happen, and we can see that by clicking on thing 1 and going over to the size inspector. Okay, so in the inspector there, I've switched over to size. This thing looks kind of like a ruler. And size inspector has, you know, where the current frame is and all that. But at the bottom, do you see where it says constraints? And I have 2 constraints. My leading space, okay, the reason that says leading space instead of left space is because some languages, leading is on the right, okay? So Hebrew or languages like that, it's on the right. So you might want your entire user interface oriented towards coming from the right, okay, instead of coming from the left, because all your text is going to be going that way. So you might want all your user interface to flow from that way. So anyway, so leading means whichever leading you're talking about. And I want the leading space to be tied to my super view, the edge of my super view, by some fixed amount. And that fixed amount is default. Default, okay? It's not a magic number, it's default. It's by the system. The system decides what that default amount is. And then you can see my top space is also tied to my super view's top edge with the default space. So those 2 constraints determine exactly where thing 1's going to be. Now what about thing 1's size? Okay? Is thing 1 always going to be exactly the width it is right now? No. Thing 1, like all labels and buttons, it has what's called an intrinsic size. Okay? That's the size that its text demands that it be. And that could change. If you change the text in thing 1, it needs to be wider or it could be shorter if you change it to something shorter. And so it will change its size as you change its text, okay? Because you haven't put a constraint on its size. If you put a constraint on its size, it would then be stuck to that size, and that is bad. We do not put size constraints generally on intrinsically sizable items like labels and buttons. And I'm going to show you, hopefully if we have time in the demo, why that's bad, okay? So anyway, thing 1 only has those 2 constraints, but those 2 constraints completely determine thing 1's location, no matter what the superview does. Same thing with thing 2, bottom space and the trailing space. Okay, so now let's go look in landscape. I'm going to switch over to landscape and see what happens. And you can see thing 2 sticks to that corner, kind of exactly what we want. Right? And that's because thing 2's position is totally determined by those rules now. Okay? Okay, so let's go back to portrait. So I'm going to put a bad thing in there. Okay, so this bad thing is going to show you bad things that can happen. And I tried to put bad thing in the middle, but I didn't use the blue guidelines. That's actually difficult to do, but I did. Okay, I put bad thing in. Also, you notice bad thing size, it's too big for itself. It really doesn't want to be that big. It could be a lot smaller if it was its intrinsic size. So I just dragged it out and moved the sizing handles. It has no constraints because I just dragged it out. Okay, see how its size inspector there says no constraints, right? You have no constraints. So what happens if I try to ask Xcode, please give me some suggested constraints for bad thing? Remember, I didn't use the blue guidelines when I dragged bad thing out. And notice also I'm using the top half of that menu, which is just for bad thing. Okay, I'm not resetting thing 1 and thing 2, although I could reset in thing 1 and thing 2 all day long because they're always going to reset to the proper constraints because I'm using the suggested constraints for them. But anyway, so I'm just going to reset bad things constraints. And boom, Xcode gives it the old college try. But it's hard, okay? And in fact, look at the constraints it came up with there. Height equals 62, leading space equals 89, trailing space 68. In other words, these are all magic numbers, okay? This is horrible. These are terrible constraints. Constraints with magic numbers are almost always bad. There's a few cases where they're okay, but it's almost always bad. And in fact, if I go and try and switch to landscape, all those numbers stay exactly the same. Okay, it stays 198 pixels from the top and whatever it was from the left. This is totally not what I want. Okay, I'm trying to put bad thing in the middle. I want it to stay in the middle. That's not even close to being in the middle. So suggested constraints aren't going to work if you don't use the blue guidelines because it's not really sure what you want. Okay, so let's get rid of these constraints. I'm going to go back to that same menu and pick a different item here, which is clear constraints, and that clears all the constraints and goes back to this thing. Notice, by the way, all the constraints draw. You see the blue bars? See them? Every single constraint is drawn. And not only does it draw those constraints, you can click on them and edit them. A lot of the constraints have attributes, which I'm not going to have time to talk about today, unfortunately. But those constraints are first-class objects inside of your storyboard. All right, so we're going to clear those out of there. And let's put in some constraints in a different way. So this is way number 2 to add constraints. Way number 1 was use blue guidelines and say suggested. That's way number 1 to put constraints on. Number 2 is you can use some of these other buttons at the bottom. Like this particular button here is for aligning things. So if you look in this, there's a lot of choices of how to align things. If I selected multiple views, then all those things at the top, like leading edges, trailing edges, top edges, I'd be able to pick those, and I could line up the leading edges or trailing edges or whatever of views, make them line up. Okay, it's just an alignment thing, just like if you're in some drawing program or something. I'm going to pick the bottom 2, which lines this thing up with the horizontal center in the super view. So it's going to be centered in my super view, both horizontally and vertically. So I'm going to add 2 constraints here, one for horizontal, one for vertical. And I can also specify an offset from the center. That's what that 0 is right there that's selected, but I'm going to have it be exactly in the center, so I'm going to say 0. And there's also update frames. You see the update frames at the bottom there right above where it says add 2 constraints. That pop up, you can go in there and say, and when you add these constraints, move my view to fit those constraints. But I'm not going to set that because I want to show you what happens if you don't do that. Okay, so let's add these 2 constraints, horizontal and vertical centering. Okay, there they are. You see them? Align center X to super view, align center Y to super view. Awesome, you can see them. They're there. Notice that they're yellow. Okay, yellow is like a warning. Okay, yellow is not good. Blue is good, yellow not so good. Red is really bad. Okay, sometimes your constraints will be red. That's if they conflict. Like you have 2 constraints saying do opposite things. And we'll talk about how we resolve all this. So it's yellow. Also, if you look really closely, you see there's a dashed box. Kind of right, it goes right through the word bad over to the thing. You see it right there, dashed box inside of the bigger box. That dashed box, I don't know how well you can see that there. Yeah, you can see it. That dashed box is where your constraints say this thing should be. Okay? In other words, if you just looked at your constraints, where should bad thing be? Well, it should be in that little dashed box. But since we didn't click that thing at the bottom there that said update my frame to where my constraints are, it didn't do it. So bad thing is still where it was. And that's why these are yellow. Okay, how can I know why my constraints are yellow? Well, one place is that little triangle in the upper corner there, the normal triangle where you would look at any other warning in your app. And you can see that it says the frame for bad thing will be different at runtime. That's because at runtime the constraints are going to be applied and it's going to be moved into that little dash box. Okay, another place you can see these warnings if your constraints are yellow is in the document outline. Now, we have not had a chance to talk about the document outline in this class, but there's really not a lot to say about it except for that it's really great. And what is it? It's every single object in your storyboard that matters in an outline form. Okay, so that's all your views, all your gestures, all your constraints, things like layout guides, which we're really not going to have a chance to talk about, but it has to do with the auto layout system as well. Those are all listed in this outline, and what's really cool is you can click on them to select, because sometimes your view is very crowded and it's hard to click on the thing you want, even using the Control-Shift trick that I showed you. And also you can control drag from them. Okay, you can control drag from a gesture, you can control drag from a view. It's a really great place to control drag things from. Okay, it's pro tip number one. Control drag from document outline. The document outline also will show you all the problems with your auto layout. And you see the tiny little yellow circle up there where it says View Controller Scene at the top of the document outline, and then there's that little yellow circle. I'm going to click on that circle, and it's going to show me all the auto layout problems in this controller, in this scene. And you can see the bad thing, it expects a certain frame, and the actual frame is different. And you see the little triangle there. If I click on that triangle, it will offer to solve the problem for me. Okay? Now, how can it solve the problem? Well, there's a number of ways it could solve the problem. It could change the frame of bad thing to be what the constraints say. That's what update frame is. It could update the constraints instead of being the vertical and horizontal center that I just sent it to. It could set them back to being something that would make the bad thing's frame work. Or it could try to set it to the suggested constraints, which we already know don't work. So we definitely want update frame in this case. Okay, we know we like our constraints. That's the horizontal vertical centering. So we're going to pick that. So I'm going to leave update frame suggested and click where it says fix misplacement. And watch what's going to happen to bad thing. It moved. Okay, now everything is no longer yellow. Bad thing's frame has been set to what the constraints demand of it. Okay. And I just hit back to go back to in the document outline. So now let's go look in landscape and see what happens to bad thing. It stays centered. Okay? Bad thing properly stays centered because the only rules it has is for it to be in the center. Okay? All right, so back to here. Okay, you can also click on, I told you could click on these constraints. So here I clicked on the vertical constraint there. You can see I just clicked on it. And you see how it's kind of highlighted. Also notice that the attribute inspector started being an inspector that's inspecting the center X alignment constraint. Okay? And there's a lot of things you can set about constraints. Notice there's a priority there because you might have layout, only complicated ones. You might have conflicting constraints. You want something to be underneath something else, but you want it to try and be in the middle of the screen. But if the screen gets really small, then you want it to just move down out of the way of the thing on top. Those kind of conflicting constraints, you can set priorities to say which is more important. Is it more important to be in the middle, or is it more important to be underneath this other view? You see what I'm saying? So you can set your priorities between 0 and 1,000. So you get up to 1,000 items could have varying priorities. I mean, generally, you're only going to use 2 or 3 different priorities in your entire application. But anyway, the other thing you can do when you have this selected is hit delete. And that deletes that constraint. And now you can see the bad thing only has this center Y constraint. So it no longer specifies where it is horizontally. And that is really bad. And now if you look at the document outline, I had not only have a little dot up there, but it's red. Okay? And if I had a constraint that was bad, here the problem is I have a lack of constraints. I don't have enough constraints to specify where bad thing is horizontally. But if I had two that conflicted, they would be red. Okay? The constraint, the lines on the screen would be red, and I would have this little red circle. So let's click on that red circle in the document outline. And here it's saying missing constraints. Okay, bad thing needs constraints for X position, it's saying, which it does. Because how else is it going to know where to put X bad thing? There's nothing that says where to put it because I took that constraint that was telling it to be in the middle away. So let's click on that red thing. And when we do, it's going to offer to fix that. And it says, let me try and add a missing constraint. And it's going to do the best it can to add a constraint or a number of constraints to make it so that at least there's not a missing constraint. This might not be the constraint you want, but you know, it's probably going to be mostly suggested constraints, but it's going to be some kind of constraint so that so the position of this thing and its size are completely specified. So in this case, since we already blue guidelined this thing to the middle and we know it's exactly in the middle, when we hit add missing constraints, it's just going to put that thing back. Okay? Now it's not putting it back because it knows I deleted it. It's just thinking, that's the best constraint that goes here because it knows this thing is dead center. So it's like, dead center thing, I'm probably going to do that. So it's really smart about what missing constraints it will put in there. Mostly it's going to use suggested constraints, but it's even smarter than just the suggestion system. Okay? So now we have no auto layout issues. We're back to having bad thing in a good spot. Now, what if I decided I don't want bad thing in the middle. I want bad thing to be stacked on top of thing 2 all the time. So I just pick up bad thing and drag it down. Well, I'll use the blue guidelines or not, but I'm just going to drag it down there and I drop it. And what happens? Well, I get the yellow guidelines again because bad thing, once again, is misplaced. That's because when you drag things to new positions, it does not change the constraints. That's important to understand. When you drag things somewhere new, the constraints stay the same. So bad things constraints are still align center X and align Y, you see? See them right there? And that's no good. So what can we do about that? Well, we probably want to delete these constraints because they no longer apply. And I showed you how to delete them by doing clear constraints. And I told you how to delete them by clicking on them and hit delete. Here's another way to delete them. You see the little cog right there where it says align center Y and align center X. There's a little cog. If you click on that, there's a little menu. You can edit it, which is exactly the same as Attributes Inspector on it. Or you can delete it. So I'll delete that one, and I'll delete that one. So now I got rid of those constraints. Bad things back to having no constraints. I just did that. I wanted to show you that there's multiple ways to get at this thing. You can also delete them by selecting them in the document outline and hitting delete. Okay? So now I have bad thing, but where it is there, it's not tied to thing 2. If I were to go landscape right now, it would not stick with thing 2 because there's no constraint that ties it to thing 2. Okay? So let's put a constraint. Here's way number 3. Okay, do you remember what ways number 1 are? Number 1 is blue guidelines suggested constraints. That's way number 1. All right? Ever got that? Number 2 is to use the little menu things at the bottom. Click, bring up the little thing, type in, click horizontal, whatever. Click the things that you want. Way number 3 is to control drag, just like you're making an outlet, between 2 items that you want to have some sort of constrained relationship. So I'm going to control drag from bad thing to thing 2. Okay? And when I do, I get a little black box, just like if I were making an outlet. But this time it's saying, what do you want to tie between these 2 items? What do you want to be fixed between these 2? So you can actually select multiple of these using Shift. That's what it says at the bottom there. Hold Shift to select multiple. So I'm going to pick the vertical spacing. I want bad thing to always be a fixed vertical space above thing 2. And I'm also going to pick right edge. Okay? And this is saying left and right, but it's really trailing and leading. It just right now it knows which is your left and right, so it's saying right to be nice to you. So I'm going to pick both vertical spacing and the right edges. Okay? When I do that, you can see I get 2 constraints. You can see them on screen too, the little blue lines in the I-beam between bad thing and thing 2. That is lining up the right edges and fixing the space between them to the default space. Okay, that's because I used the blue guidelines. If I hadn't used the blue guidelines and had put bad thing 40 pixels above, then it would have fixed it to 40 pixels. But we would have seen in the constraints 40, and we said, oh, magic numbers and constraints, better fix that. Okay, which you can do by editing the constraint, and just there's a button actually that says make it the default. All right? So now I have these two things tied in that way. Again, this is totally enough to specify all of their positions exactly, because thing 2 is tied to the corner, and bad thing is tied to the right edge and just above thing 2. So if we go to landscape again, bad thing will always stay that distance and always to the right edge of thing 2. Okay? So that's way number 3 to attach things, is to control drag between them. And you can control drag between items, between views. You can also control drag from a view to its super view. That's what I'm doing here, bad thing to its super view, and you'll get a different set of options like horizontal and vertical container. Or you can also control drag to yourself. Okay? Why would you ever control drag to yourself? Well, bad thing, why would I control drag bad thing to itself? Well, then I'll get the option to do things like fix bad things width. Okay, which I told you is bad anytime you have a button or a label or anything that has, you know, an intrinsic size like that. It'll also, if there's some nearby thing it could do, like fix the trailing space to its container, it could do that for you too. But you can control drag to yourself too, which sounds crazy, but you'll get used to doing that. So control drag is way number 3 to set up constraints. Okay? So there is a lot to this system. I've just tried to kind of show you where to look for everything, how to click on things, where to inspect them, where to see the constraints, how to go in the document outline to resolve problems, whether they be red or yellow. It would take me many lectures to cover all the different kinds of constraints that you can set up. And, you know, for example, do you see in the inspector there where it says content hugging priority and content compression resistance priority? That hugging priority, that's not because these views love each other, but sometimes they do. But mostly the hugging priority is because you have sometimes views that are sharing some horizontal or vertical space. And when they share and that space gets removed from them or gets taken away or they get more space added to them, they need to know which of those views wants to keep its size the most and which of them wants to get extra and which is willing to be compressed and which is not willing to be compressed. Thus you have compression resistance priority and content hugging priority. Okay? So that's as much as I'm going to say about those. You've got to read up on those if you're going to do that. You're not going to be building UIs, I don't think, like that in your homework. If you are, more power to you to go look up content hugging and content compression resistances. Okay? The last thing there you see is intrinsic size. Again, a bunch of iOS things have an intrinsic size like labels and buttons, but you could actually have your own custom views. Again, not for your homework. You could have your own custom views that have their own intrinsic size. They just have to implement a little API that reports their intrinsic size, and that little pop-up there lets you tell Xcode how to handle that because it doesn't really know how to handle that for non-system objects like labels and buttons. Okay? So the demo I'm going to do is I'm going to take attributor, which hopefully you still remember attributor from 3 lectures ago or whatever it was. And we're going to make attributor so it auto-rotates and looks good. Attributor is the thing that had the text and we could outline it and pick the colors. Remember that? So we're going to make that do that. We use the guidelines when we built attributor, so it's going to be really easy to make this work. Okay, but I just want to show you what it all looks like to make it go. And I'll do this slide because we'll finish with the demo. On Friday, I'm still hoping to get this Universal Developer thing going. Again, I'm not going to require any of you to get the thing working on your device until I can get you into this program, so no worries there. And those of you who are doing the $99 program, you're all good to go. Hopefully, it's all just working for you. Your homework, as you know, is due on Monday. And next week, we're going to do scroll view and table view. Actually, we probably won't do collection view the more I think about it. And the other thing we're going to do next week is iPad. Because everything we've done so far is iPhone. It's time to start doing some iPad. Okay? So let's go back to attributor. So I'm going to get Xcode up here. And let's close drop it. Stop that task. We can quit that. And sorry, let's go back here. And I'm just going to bring up attributor as we last left it here. Remember, this is what attributor's user interface looks like here. We don't need to see the code at all today because we're going to do all of this auto layout stuff in Xcode. And let's see what attributor does right now. So let's run attributor just as we left it off. And here it is. There's attributor. Remember, we can do this kind of stuff, pick these things. And if we rotate, and everyone saw on Piazza the way we rotate is we hold down the command key. It's basically this right here, command arrow. Okay, so I'm going to do command arrow. That looks pretty bad. Okay, in fact, that's horrible because we've lost all of our control. No outline, no colors. We can't really do anything here. Stats still looks okay, but it's kind of cut off. That's not so good. Dot, dot, dot. So really, this whole UI did not react well. And so let's try and fix it so that it stops doing that. And this is going to be in some ways almost too easy because we dragged all these things out using the guidelines. So I'm just going to go down here to the TIE fighter, and I'm going to say reset to suggested constraints. And pretty much that's going to do it. So let's just rerun. Okay, we could make a quick look at some of these constraints just to see what it's doing. But like this, let's get this out of the way in here. So you can see that this thing is tied to the super view on the left. It's lined up with the buttons. It makes a little space in between the buttons, a little space at the top. So it's pretty much doing what we want. Let's see what happens when we rotate now. So we got this. It's still all working. Nothing has broken because of our putting those constraints in. And so we'll rotate. Ooh, that looks pretty good. I can still, for example, set my outline. I can set colors. It's great. Stats. Oh, much better. However, this is not so good. Okay? I like purple, but not that much. Okay? So we got to make these things all the same size. We want these 4 buttons to be the same size. Okay? Nothing that we did when we dragged it in, evidently, was enough to let Xcode know that. However, so simple to make that happen. I'm just going to select these 4 buttons. I'm going to go down here to this little constraint adder right here. And I'm just going to click this button that says, I want these 4 buttons to have equal widths. In other words, I'm adding the constraint that their widths be the same. Okay? So when I hit add 3 constraints, it's going to add 1 constraint to each of them, probably, each of these first 3, saying be the same as the next one over. We'll do that. And you can even see that. See, here's what they look like. Equals. See? So let's go and run. See if that fixed it. And it did. Okay. So whichever way. By the way, why does it not rotate here? Because this is the upside down, portrait upside down. And in our project settings, we said we don't support portrait upside down. So that's why it just does nothing. When you go to portrait upside down, it does nothing. But when we stay with portrait right side up, or between either of the 2 landscapes, it seems to be doing exactly what we want here in this view. And the only problem is, if we look at our console, we're getting all kinds of errors here. Okay? This doesn't look too good. Okay? And what is this primary error we're getting? Unable to simultaneously satisfy constraints. Okay? So this looked all good over here. There was no, I don't see anything, there's no yellow things. If I bring up my document outline, there's nothing yellow here. My auto layout constraints are good. Well, actually they're not, okay? Because it's unable to satisfy the constraints at runtime, okay? Well, why is that happening? Well, it actually gives you a lot of help as to why that's happening. Let me make this wider. Here, and it gives you even kind of ASCII text kind of descriptions of the layouts. You see how everything's laid out? But I can probably guess already that since I just introduced this error, it has something to do with what I just did, okay? Which is to make those widths be the same. So let's take a look at the constraints of these buttons and see if we can see something obvious, okay? Anyone see anything obvious in here that doesn't look very good? Speak up.
The width equals 64, it's hard-coded?
Yeah, the width equals 64 here is hard-coded. Okay, that's a magic number. That's bad. And in fact, we know that when we go to landscape, the width's not going to be 64 anyway, right? They all get a little wider in landscape. So this is the problem. It's trying to make those buttons all the same width, but it's trying to keep them all 64, or at least to keep this one and this one and this one 64. This one seems to not have that 64, which is nice. So this is easy to fix. I'm just going to delete these width equals 64. It's not the height equals 64. So let's delete the width equals 64. Let's delete this width equals 64. And we'll delete this one. Okay? So this height, nothing turned yellow. Okay? Nothing was like missing constraints. Okay? It's all completely still specified. And now if we run, Okay, and we rotate back and forth. Still working, still making the buttons wider, and we're not getting, okay? So sometimes you'll get the constraints. They won't have any problems in Xcode, but you still might have some conflict. So you should be looking at your console to see if there's conflicts. Question?
Why did you keep the height equals 64 magic number?
Okay, so the question is, why did I keep the height equals 64 magic number? And that's a super good question. Now, it's okay that I have a magic number here. And why is that okay here? That's because there's no text in that button. It's almost like an image, right? So what size would it be otherwise? There's nothing, if you look from top to bottom in this view, there's nothing that would specify what size it is, because this is not a fixed width, or height rather. This is a fixed height, and so is this and this. But then how much space goes to this and how much goes to this? By fixing this one at 64, this one gets the rest. Now, I actually could do this another way. If I kind of wanted, the text view to have most of the space and this, some of it, and I want it to be a minimum size, I could actually set the size here to be greater than or equal to some particular size. And I could use the content hugging priority and compression priority between these two to make sure that whichever one I wanted to get the extra space when it got taller, like this, okay, I could make that be defined. But by fixing this one, I'm guaranteeing this one gets all the extra space. So when you have an image, I said that sometimes a magic number is okay. Usually it's when you have an image. Some artwork that somebody has drawn has a size to it that's its size. And here, these squares, I want them to be this size. So I'm glad you brought that up. That's a good question. Okay, the other thing I'm going to do here is play around with this. So this is working fine. Nothing to change here. What about this guy over here? Well, this one's pretty bad. I kind of drag these in here without using the lines or something, so they're kind of in random spots. So here's a good chance to show you how to put these things in their place, not using suggested constraints. Okay, in other words, actually specifying. So I'll show you both ways to do it, both non-suggested constraints. So let's put outline text in this corner down here, or we'll put colorful down there, whichever. And then we'll have the other one stack on top of it. So I eventually want it to look like this and this, but I'm not going to use the guidelines, okay? Because I want to show you a different way to do it. So here I have colorful characters. So it has no constraints currently, because when I said reset suggested constraints, I was doing that for this guy only, right? When you go here to the TIE Fighter, it says in attributor view controller. It doesn't say stats view controller, so it only did it in that one. And I didn't reset it here, so these things have no constraints. So let's set this one to be in this lower left-hand corner without using the guidelines. So I'm going to do that with this guy, okay? So this little button right here, it lets you specify, this is where we did equal widths. But here I only have one thing selected, so I can't even pick equal widths. I'd have to pick two things for that. But up here at the top, you'll notice you can specify that this thing is tied to views around it, either it's super view or to other views. Okay? And also, I can pick the standard value here. So I'm using the default value, okay, which you generally want to do. You don't want to have magic number like 171 in here. But I'm not picking these I-beams, so those are not going to be affected. And you see it wants to add those two constraints. That's this one and this one. I'm also going to show you this, update frames. You can update the frames, in other words, move the view as it currently is showing in the scene, either all the frames in the entire container or just the frames that got new constraints. Usually you're going to pick this one, items with new constraints. So I'm going to hit this, and what's going to happen? That colorful thing is going to jump to lower left-hand corner, standard distance away, automatically. Okay? So that's another way to set the constraints. See, it's put standard distances here. It's got these standard constraints. And how about this guy? We want this guy to be lined up on top of this one. We could do that also with this. Okay, we could set the I-beam here and all that stuff. But I'm going to use the control dragging to do that. So I'm hold down control, and I'm drag from this guy to this guy. And I'm going to have the vertical spacing. I'm using shift, by the way. Vertical spacing and left, in this case, the left edge. I want those lined up. And then I'm just going to hit return. And it created me two constraints for that. Bottom space and colorful character. So let's go see what that looks like. All right, so we have this. We do stats. It stays in the lower left, whether we're portrait or landscape. So that worked perfectly, and they stay stacked on each other. One thing I want to show you is this. Watch this. Let's pick a whole bunch of text here and make it outlined and colored and go to stats. And you see how these nicely show the whole word 226 colorful characters. In other words, they don't get cut off. That's because these two things are their intrinsic size. What happens if instead I fix the size of one? And this is why you're going to see these intrinsic size being fixed is bad. So I'm going to take this colorful character one, I'm going to fix its width. And I'm going to do that by control dragging to itself, okay, and saying width. I could also do it with these buttons down here. And there it is, width equals 157, which is its current width. I'm just going to leave it that way. Okay, now let's run, see what happens. Okay, so it seems like no problem, everything's good. But let's select a lot of text again. Oh, not so good. You see? Since this thing is not its intrinsic size, it couldn't fit when I went to 127 characters instead of 0, right? So it just went dot, dot, dot. I can't fit. Okay, that it always does. You can control this, but by default it does this dot, dot, dot if it can't fit. Okay, so do you see the hazards of having these hardwired widths in here? So if I take this and delete it and run again, now when we go to the stats, even if we have a lot of stuff, it'll fit. Okay? All right. One other thing I guess I'll show you real quick is what happens. Let me show you the document outline piece of this. Okay, so nothing's wrong in here, but I'm going to make something wrong. Let me go to this guy and let's delete its align leading. Okay, so it's no longer lined up with this. Okay, when I do that, notice this one turns yellow because it is a constraint for an object that has problems. Okay, so anytime you have an object that has problems, all its constraints will be yellow or even red if they're conflicting. So you can see we've got this little red guy here saying that there's a problem with this guy. And we know what the problem is, right? We don't know where it is horizontally. We only know where it is vertically. Okay, so let's go do that. And it says needs constraint for X position. Again, I can click on this little red thing. It'll say add missing constraints. It's smart. It knows these two were lined up on the left. It said it's nearby. It said, oh, probably wants to be left aligned. So we'll put a left align in there. Okay. One other thing I'll show you real quick. You see you move this guy. Okay, you see how now these are yellow because this doesn't match up. This is where the dotted box is. Again, in the outline, if I click this, I have these choices up here. I'll update the frame to put it back. One other thing, notice that in all this moving around, this got set to 8 instead of the standard space. That sometimes happens. I'm not really sure why it lost its default space. We didn't really do anything to specify that. But you can edit, select and edit, or you can even, okay, so we could edit here and change this to standard, or watch this little trick. You see that little guy? I'm going to double click on that. Okay, if you double click on a constraint, all this stuff will appear right where you are. So in this case, I'm going to switch from 8 to the standard value. Okay, when I hit return. 8 is the standard value, it turns out, so nothing changed. But just wanted to show you there how you can double click on a constraint to set things like its priority and stuff like that. Okay, so that's it. For your homework, you only have a little bit of auto layout to do because you only have, besides the card containing view, you may have redill, add more cards, score, I don't know, because I let you delete some of the other stuff from previous assignments. So auto layout should be pretty simple for this. But for the rest of this class, all quarter long, you should always be using auto layout. Your app should always work in landscape and portrait for the rest of this class. Okay, all assignments. It'll be in the assignments, but just so you know. Thank you very much.
For more, please visit us at stanford.edu.